Howdy! Today we're going to be solving our first problem from Coulomb's law. In this problem we have two equal charged particles, Q1 and Q2. So their magnitudes are equal to each other. And they're both acting on point Q0. And so what we want to find out in this question is, what is the force on Q0 acted on by Q1 and Q2? So let's draw out the forces they create. Since they're both positive, we know we can draw these forces going away from Q0 because they're repelled to each other. Let's call this force F1 and let's call this one F2. So F of Q0 will be equal to F1 plus F2. And then we're going to use Coulomb's law to solve this. So let's go ahead and write that out. Coulomb's law states that the force acted on by two charged particles is equal to their magnitudes times constant K divided by the distance between them squared. So since F1 and F2 are both diagonal vectors, we're going to need to do their x and y components. So let's start with plugging in F1 into Coulomb's law using both of their components. So F1, let's do the x component first. So it'll be K. We know it's coming from Q1. So Q1 and Q0 it's acting on. And then the distance between Q0 and Q1 is just this hypotenuse right here. And I forgot to write in these variables. So since these are equal distance, it's A and then the height is H. So we know that distance between them is going to be the square root of h squared plus a squared. But since it's a squared, we can just write a squared plus h squared. And since we're doing the x component, we're going to write in cosine of theta ix. And then we can add the y component, which is the same exact thing, just with sine theta. So to simplify this further, let's find out what cosine theta is. So cosine theta, so let's show how we can find this. We can draw a parallel x-axis and we can say this is theta. So if that's theta, we know cosine is just adjacent over hypotenuse. The adjacent would be A. A over the hypotenuse we just figured out was the square root of h squared plus a squared. And let's do the same for sine. Sine is opposite over hypotenuse. The opposite would be h. Okay, so now we can plug in this into cosine theta and this into the sine theta. So let's write it again. Let's write it as simplified as possible. So F1 is K, Q1, Q0, A, and then the denominators will simplify to the 3/2. So we know these were both positive because the x was going to the right and the y was going up. So we didn't have to worry about that. But when we look at F2, we know that the x is going to be going to the left, which means we need to take that into account by putting a negative. So let me just box this, and let's start with F2. This will have the same denominator. And remember, the negative goes in front. So notice how the only difference here is the negative and writing Q2, but in reality it's the same because Q2 is equal to Q1. So we can plug back in the same cosine and sine we just found, and we'll get the same thing as we got for F1. The only difference would be that the x component of F2 is negative. So we know we can actually cancel these out. And this would have been pretty obvious if we just looked at the picture. We can see that these x components cancel out, but I solved it to show that anyways. So now we can actually get our final answer, since we have the y components of both F1 and F2. So let's go ahead and write that out. So the force on Q0 will be 2, since we have the same thing twice, times K, and we can either pick Q1 or Q2. They're equal to each other, so it's okay to pick either one. And then this would be IY, since it's just the y component. And that would be the final answer for this problem.